everyone, and welcome to our Education Minute. And this is our virtual discussion on general mathematics, specifically on the introduction to functions. So, we have given to you a lot of reading materials already through our learning management system, but this video might be helpful for you to further understand the concepts on functions versus relations. So, let's keep going. Before, we will be giving to you a lot of practice exercises through our synchronous discussion. Hopefully, you will be able to watch and listen to this video so that we have a full grasp of understanding on the concepts on functions versus relations. And so, first and foremost, let us define what a function really is. A function is special, but a function has special rules. It must work for every possible input value, and it has only one relationship for each input value. What does it mean? Simply stating, we can define function as a relation wherein each element in the x value or in the domain corresponds to exactly one element in our y value or in the range. As you can see in our illustration on the screen, a function relates each element of x in the first set of variables to exactly one element into the another set, which is considered to be our range or our y variables. So you can see here that each element in the x corresponds to exactly one element in our y. That means whatever is our input in here, there's corresponds exactly one output. And that is, I think, one of the very considerations of function. There are two very important phrases on the definition. First is that each element, and second is the exactly one. So, in each element means that every element in x is related to some element in y. And that exactly one means that whatever is our input, it corresponds to exactly one output. So for every x, there corresponds exactly one and only one value of y. We can look at our function model as a function machine, wherein our outputs depend on the inputs that we have. I'll say a very simple analogy of that is, for example, when we are going to have a fruit shake, for example, our output shake, would depend, of course, on the fruit that we are using in our shake. So, for example, when we have a mango shake, it's a mango shake because our input is a mango. So, that's a very simple analogy of that. A function is a relation in which one element of the domain is paired with exactly one element of the range. That means that there is one and only one output with each input. So let's have this function notation. Our y in here is our output, while f is our name of function, and x is our input. Okay, so that means our output y here would depend on whatever is our input x in here. Okay, so there are also very much important terms that we need to consider. We talk about the domain of a function and the range of a function. The domain of a function is the set of all our x coordinates in the set of ordered pairs. So our x coordinates in the set of ordered pairs are our first set of variables in an ordered pair, or these are our input. Our input, which are considered to be our independent variables. While the range of a function is the set of all y coordinates in the set of ordered pairs. These are our second set of elements in the ordered pairs. Range, okay, or the y coordinates are our dependent variables. So these are our outputs. Again, domain x coordinates are our input. These are independent variables. While the range of a function are our y coordinates, These are our outputs or our dependent variables. We define function as a relation wherein x element, wherein the first set of element corresponds to exactly one and only one value in the second set of elements. So therefore, function is a relation. However, not all relations are functions. So what is the difference between a function and a relation? Simply saying, we could say that functions, all functions are relations. However, not all relations are functions. Okay? So a function, we define function as a function is that the elements of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. And that, I think, that is the very main difference of a function to a relation, because a function, each input corresponds to exactly only one output. While when we talk about relations, okay, the inputs can generate one or more outputs. So if a relation, the relations that the input generate only to one output, that is what we call the functions. However, relations can generate to more than one output. So therefore, if that relation generate to more than one outputs, those are not considered to be functions anymore. Because again, in a function, each element in the domain is related to only one value in the range by some rule. So for example, a relation in a set of ordered pairs, it's a set of ordered pairs, while a function is a relation such that no two ordered pairs have the same x value but different y values. So let's have this one as examples. Okay? So, let's identify if the following is a function or not. Number one, a jeepney and its plate number. A jeepney and its plate number is a function. Why do you think so? It is a function because, again, a jeepney corresponds to exactly one plate number, or every jeepney has its own unique plate number. There is no jeepney having two plate numbers, correct? So therefore, it is a function because there's exactly one element that corresponds to our input. Second, a student and his ID number. Every student has its own ID number. So whatever input, there's exactly one output. So a student has its own unique ID number. There is no student having two ID numbers in a school, correct? So therefore, number 2 can be considered as a function, correct? Number 3, a teacher and his cellular phone. However, a teacher could have two cellular phones. So it could be for example, Sir Koyoka. Sir Koyoka is having two cellular phones. So therefore, for every input, there are two or more outputs. So number 3 is a relation. Number 3 is not a function. As well as number 4. Because again, a pen and the color of its ink, we have pens having two or more colors. Correct? So on this case, number 4 is not a function. It is only a relation. So let's try to illustrate functions even more. Okay? So in our example in here, so again, let's try to illustrate functions in here. Functions can be represented in a lot of manner, in a lot of ways. And the first one is that functions can be represented as a set of ordered pairs, x and y. As I've mentioned earlier, we say function is a set of ordered pairs, x and y. Our first element in a set of ordered pair is what we call as our x, or these are our independent variables or our domain. These are our inputs. While the second element or the y second element is our dependent variables, which are considered to be our range or our outputs. So therefore, our range depends on our domain, since the domain is an independent variable. So independent variable, therefore it is our input. Okay, our output depends on our input. So that is our set of ordered pairs. So you can see here below the illustration, we have our set of ordered pairs. So as you can see, our x element 3 corresponds to exactly only one element in our range, which is 2. Okay, so there's no other 3 in here as our first element. So it's only 3 paired with 2. 4 being paired with 0, 5 with 1, and 2 as 3. Our domain in the set of ordered pairs are 3, 4, 5, and 2, because these are our inputs, our first element, our independent variable. While our range in the set of example are 2, 0, 1, and 3. These are our dependent variables or our outputs. Another way of illustrating or writing function is that it can be represented in a diagram. In a diagram, wherein again, the first set of elements are our independent variables or our domain or our input. So in this example, 3, 4, and 5 are our domain, okay, and A, B, and C are our range. So as you have observed, 3 corresponds to exactly one value, which is A. 4 corresponds exactly to one value, which is B, and 5 corresponds exactly to one value, which is C. So that is a function represented by a diagram. The third way of representing function is through graphing. That means we graph it, we illustrate it. And in identifying graphs that are functions, we make use of a vertical line test. Vertical line, V, vertical line, so standing line. If any vertical line passes through more than one point in the graph, then that relation is not a function. Why? Because if your vertical line passes through more than one point, that means that for that value of x, there are 2 or more values of y. So therefore, it is not a function. It is just simply a relation. So how do we know if it's a function? Our vertical line must pass through exactly only one point, as what is here presented in our graphing. So in our first illustration here, you can see that we try to look at our blue vertical line. It passes only through one point in the graph. So that means for every value of x, there corresponds exactly one value of y. Therefore, it is a function. All right, do you understand? So let's try to have some examples. Let's try to determine whether each relation is a function by these examples. Okay, determine whether each relation is a function. Okay, it's a set of ordered pairs. Try to examine, is this a function or a relation? Again, our x elements must correspond to exactly one element in the y. So we have, okay, can you try to guess? Right, what's your answer? Very good. Yes, that is correct. This example is a function. Why? Because every domain is different. So that means 2 is paired with 3, 3 to 0, 5 to 2, and then 4 to 3. So every domain is different. For every value of x, there corresponds exactly one value of y. Therefore, that is a function. How about this second example? 4 is paired with 1, 5, 2, 5 is paired to 3, 6 is paired with 6, 1 is paired with 9. So is it a function or not? Correct. It's not a function. Why? Because again, as you can see here, 5 is paired with two numbers. And it must be that for every value of x, there must be only one value of y. So therefore, 5 here is paired with two numbers, 2 and 3. Therefore, it is not a function. It is just a relation. Right, very good. Right, so very good, everyone. Those are our examples of functions versus relations. I hope that this video is able to somehow make you understand better what a function and a relation is, always try to remember that functions are relations. However, not all relations are functions. Because again, function is a relation wherein each element of x corresponds to exactly one element value in y. For every input, there must be exactly one output. All right? So if an input corresponds to more than two outputs, then therefore that is not a function already. That is just a relation. All right? So that is all for today's session. And for our next session, we are to talk about the types of functions. All right? So thank you so much for watching this video, and I hope you learned something. See you on our next session.